Hi everyone, we are doing CA2 2014 Booklet B. Right, question 16. Diagram below shows what happens during fertilization in a human. So you're supposed to identify A, B, A and B. So A is quite obviously is the egg, alright, and B will be the sperm that tries to go into the egg. And for part B, you're supposed to name the reproductive organ, alright, that produces cell B. So if we know that cell B is a sperm, so the organ that produces it will be the testis. Alright, so here are your answers. So egg or ovum, B is sperm, and then part B will be testis. Right, question 17, you're supposed to study the diagram below. So I got life cycle of an animal. So it's broken up into two parts, 3 stages and then 4 stages. In 3 stages, young look like the adult with P. So basically P has 3 stages and the young looks like the adult. For Q, it's 3 stage where young does not look like the adult. For R will be 4 stages and the young does not look like the adult. And so when they ask you for the characteristics of R, basically what they are looking for will be these two. Okay, because you don't know anything else about R, whether it has wings, whether it can fly, you have no idea what R is. So only based on this diagram, these are the two characteristics. And because I'm asking for characteristics, for S, it's plural. So basically what I'm looking for is that R has 4 stages in its life cycle and the young does not look like the adult. So you have to give both. For B, you're supposed to give an example of P, Q and R. So P is basically 3 stage, young looks like the adult. Q is 3 stage, young does not look like the adult. And the only example I can think of now is actually a frog. P, there are many examples, chicken, human beings, we are all 3 stage, and the young looks like the adult. And for R, 4 stage will be your basically your insects, butterfly, your mosquito, and all the rest. Okay, so remember when we talk about whether it looks like the adult or does not look like the adult, chickens, some of you may think that chick does not look like the adult because one is yellow, the other one is not yellow. So basically, when we talk about looks like adult, when we say it looks like the adult, it means the characteristics. Okay, so what we're looking for is the characteristics. That means if let's say for a chicken, it has wings, it has 2 legs, it has a beak. So therefore, it looks like the adult. But for the frog has for the tadpole, it has tail, no legs, it has gills. But the adult frog has 4 legs and it has no gills. So that's what we mean by it does not look like the adult. And like for mosquito or butterfly starts off with caterpillar. Caterpillar is like a worm, but the butterfly is a different, looks differently altogether. It has wings and all the rest. Okay, so that's what we mean by when we say looks like the adult or does not look like the adult. It's basically the characteristics or the features. Alright? So here are some, this is just one example of P, Q and R. P, there are many more, R, there are many more. Alright? So the diagram below shows a water cycle. So I have water vapor and I have rain here. So from rain it goes down. So what happens here? So you know that after it rains it will form water, where it will either go to the seawater or it will go to the rivers and etc. Alright, then it will change into water vapor, and after water vapor it will form clouds. Okay, so this is how the water cycle occurs. So I'm looking for the process of A and B. So what is A? So A will be condensation, because water vapor will condense into clouds, into water droplets, and then form clouds. B will be evaporation, because from the sea waters, the river and all this thing, it will evaporate into water vapor. Okay? So I'm supposed to tick the appropriate box to indicate if there's heat gain or heat loss. So for A, which is condensation, basically it will be heat loss. Okay. So A will be heat loss, and B, evaporation, heat gain. Alright. Now number 19, duckweed cannot live in polluted water. So some of you are asking what is duckweed, so I'll just very quickly show you a picture of a duckweed. Basically this is a picture of many duckweeds. So basically duckweeds are very small, tiny plants that floats on water. So it's a water plant, but it's a floating water plant. Alright, so duckweed cannot live in polluted water, so she wanted to conduct an experiment to find out, what does she want to find out? which location has the most polluted water. So she carried out this whole experiment, and these are the observations that she has. So for K, you notice that the number of duckweed was the least as compared to the rest. For N, actually the duckweed increased. Okay, so you're supposed to answer this question based on her observations. That means based on this whole entire table here. Alright, which location has the most polluted water? I want the most polluted water. So we know for sure that duckweeds cannot live in polluted water. So if there is pollution, it means the duckweeds cannot live. So it's very obvious that K is the one that will not be able to survive. And K is the one that has the most polluted water. And so what's the reason? The reason is because at the end of the experiment, at day 7, this has the least number of duckweeds. Or in other words, you can say that the number of duckweeds decreased the most. Okay, now because I'm asking for most, I'm looking for a comparative answer. So your answer must consist of comparative words, otherwise it will be wrong. Okay, so answer will be K, and the reason is because the number, alright, the number of duckweeds decreased the most from day 1 to day 7. So now you have to mention up to day 7, okay, because it's not complete if you just stop at day 3. You need to move on all the way to day 7. Now suggest how factories along a river may cause water pollution. So basically anything that they dump into the water, be it toxic chemicals or even rubbish, that will cause pollution. Okay, so when factories release toxic waste into the river, so that's how they cause factories cause water pollution. Now question 20, Joe wanted to find out if the amount of exposed surface area of the ice will affect the rate of melting. So he wants to find out the amount of exposed surface area of the ice and how it affects the rate of melting of the ice. So initially he has 200 ml of crushed ice. So now if you look at crushed ice, it is very small particles. So if it's very small, then each piece, the exposed surface area is quite a bit, correct? Because they are very small. So all the pieces are actually exposed to the surrounding air. Okay? So how should he set up beaker B? So you need to think a little bit carefully. So what is the variable that is changing? Because for an experiment, I can only have one variable that is changing. So variable that changes is exposed surface area. So if this has a lot of exposed surface area, what would be the other beaker like? So obviously this one has a lot of exposed surface area, so definitely this part here will have less exposed surface area. Okay, so that's the key concept here. So it needs to have less exposed surface area. So how are you going to draw it? Basically what you're going to draw is you're going to draw things like this. So these are going to be your ice cubes, and you need to make sure that it's 200 ml. Okay, so in your drawing it must look about the same, because in order for it to be a fair test, I cannot use less than 200 ml. Then the amount of water is different. Okay, so I must use the same amount of water, but instead of crushing it, I leave it as ice cubes. So because they are ice cubes, they are bigger, the amount of exposed surface area will be lesser as compared to if I crush it, because each piece will have a lot of exposed surface area. Okay, I hope you can picture and understand it. Alright, if you don't understand, please ask. So now part B, what should Joe measure? So I want to know what he should measure in order to find out how the amount of exposed surface area affects the rate. So how do I know whether something melts faster? Well, you can measure two things. One, you can measure the time taken for the ice to melt completely, because rate of melting, both ice will be melting, but one will melt faster. So how do I know which one is faster? Is when it finished melting. So the one that finished melting will definitely be the one that melts faster. Or after a set time, let's say 3 minutes or 5 minutes, you measure the amount of ice left. Okay, so how you measure amount of ice left is you measure the water that's melted lah. Basically, you drain out the water and then you measure how much water is there left. Okay, so you can either measure the amount of water or the amount of ice left. All right. So your answer can look something like this. The time taken for ice to melt completely. Now this is key. Completely. This word is key because, like I said, both are melting. but which is the one that melts completely. Alright, so that will determine which is the one that melts faster. Right, let's look at question 21. So what John did was he placed 6 ice cubes into 2 similar glass cups. Now then he placed one glass into a glass container as shown here. Alright, filled both glass cups with the same volume of water at 25 degrees Celsius. Okay, so then he measured the time taken for the ice cubes to melt. So this graph shows the amount of ice versus time. So as time passed, the amount of ice dropped for both. Now, the question is asking you to base your answer on the graph. So you have to only base on this graph alone. Which setup, X or Y, did the ice melt faster? You're supposed to explain your answer. So basically you can ignore this part here, okay, and just look solely on the graph. So if I want the ice to melt faster, so now what does that mean? So that means that the amount of ice will get lesser the faster, or rather the amount of ice will be gone, because if it melts means there's no more ice, correct? So the one that melts faster will be the one that the amount of ice gets lesser the fastest, and so that's X, because X went down to 0 the fastest. So X will be your answer. Well, most of you were able to answer and give X as the answer, but your explanation must be based on the graph, cannot be based on what you see here, okay, because they're asking for based on the graph. So it's very important to read the question and find out what they are looking for. So basically X, and the reason is the amount of ice decreased faster. So there are certain keywords that you must have. Comparative, because we're comparing X and Y, so you must always use comparative words. So the amount of ice decreased faster than Y in the same period of time. So let's say we take the same period. X decreased faster than Y. Now part B, glasses with double walls, okay, reduce the amount of water droplets condensing on the outside, okay, when ice water is placed inside the glass. So explain why this is so. Now basically you need to understand what the double wall is. This double wall is what they call insulated cups. Okay, so what this double wall has over here is actually, what do you think? Yeah, it's air. Okay, so these double walls have air, and you need to recall something. What are some of the properties of air in terms of, in this case, what is it that causes condensation? Heat. Am I right? So in the light of heat, what concept or what do we know about heat and air? Well, so if you recall, air is a poor conductor of heat. Now this is key. This concept is so important. Air is a poor conductor of heat. Okay, now because air is a poor conductor of heat, this part here, the heat cannot go in. Now because in a normal glass, what happens is the heat goes in, because heat flows from a warmer to a cooler region. So my glass will cool down. And so when my glass cools down, what's going to happen is that the water vapor in the air comes into contact with the cooler surface, loses heat, and then it changes into water droplets. Now because air is a poor conductor of heat, so heat is not going to go in. Okay, my heat is not going to go in. This is not going to happen. So which means that this part here will still remain warm, and that's why you don't see water droplets condensing, because this part outside the cup basically doesn't cool down. Alright, so how you give your answer will be like this: air between the double glass walls, and the glass is a poor conductor of heat. Okay, so the first part is you must actually mention that air is a poor conductor of heat. Okay, and because of that, it prevents the surrounding air from condensing on the surface of the glass, as the surface of the glass does not get cooler. Okay, so the 8 here refers to the surface of the glass. Okay, now question 22. Basically what this experiment is I have this whole setup. I have warm water with red food coloring, Okay, and if I have empty bowl placed in the middle, I have this coin on this plastic sheet, and that's covering the pot. Okay, so after an hour, what is the color of the liquid that's collected in this bowl? Now, what you must understand is that evaporation only occurs in water. Okay, so I'm just going to write this down to make it clearer. Only water evaporates. Okay, so now this is key. Okay, only water evaporates. That means this red food coloring is not going to evaporate. Alright, because evaporation is basically changing of liquid to gas, and only water changes from that liquid to that gas. Okay, the red food coloring and all the rest of the impurities and everything else does not change into gas. Okay, so what's going to happen is that the water vapor is going to rise. Okay, it's going to rise. Now when it touches this plastic wrap, because the plastic wrap is cooler, am I right? So it's going to lose heat and it's going to change to water droplets. So then, because of the coin here, it creates like it creates a slope. So due to gravity, the water droplets is going to travel down, and finally it will drip into the bowl. So what's going to be collected here is pure water. No food coloring, nothing in. So what is the color of the liquid that will be collected? Basically it's pure water. So what color is pure water? There's no color. So colorless, or you can say clear. Alright. So describe how the liquid is collected. So basically I've done that description. So there are a few parts which I will emphasize after I've tapped it down. Okay, so for 1.5 mark, the first half mark is where you are able to tell me that the warm water vapor, the warm water in the container evaporates to form water vapor. Half mark. Now then you must be able to tell me that the water vapor then rises and touches the cooler surface of the plastic wrap, loses heat, changes into water droplets. So this is the whole idea of condensation. Another half mark. And then finally, how does it get into the bowl? It's because the water droplets accumulate and drip into the bowl and drop into the bowl. Okay? So that is how you get your 1.5 marks. Now question 23. Haziq wanted to find out if liquid Y evaporates faster than liquid Z. So this is his aim, whether Y evaporates faster than Z. Okay? So he carried out an experiment here. So I've got Y here, I've got Z here, I've got this fan here, and nothing here. So based on the experiment, is this experiment a fair one? You explain your answer. So basically, what he's trying to find out is whether Y evaporates faster than Z. So that's his variable that he's testing. But in this case, I have this fan here. So if I have this fan here, I have no fan here. This is not fair because I'm changing two variables. So in setup A, I have fan and liquid Y. Setup B, no fan and liquid Z. So it's not fair because there are two variables that are being changed. Okay, so that's how you should explain your answer. So his experiment is not fair? No. Reason being, only the type of liquid should be changed. Okay, this is if I want it to be a fair test. Now also because changing the amount of wind would also cause changes in the rate of evaporation. So it will cause his results to be wrong. Okay, now a lot of you just mentioned that A has a fan. Now that's not enough because you're just stating what you observe from this, which is good, but you need to explain further that in an experiment to be fair, because they're asking for why is his experiment not fair. So in order for your experiment to be fair, you need to only change one variable. So your answer must be able to explain that only one variable must be changed in order for an experiment to be fair. Okay? So besides measuring the time taken for the t-shirt to dry completely, so they already told you besides doing this, so you can't do this. So what else can he measure? So if I want to find out which liquid dries faster, well, what I can do is I can either measure the mass, because if I use the same amount of liquid for both, the mass of the t-shirt
at the start of the experiment should be the same. But if, let's say, Z evaporates faster, then the mass of this shirt here will be much lesser compared to Y. So either you measure the mass of the t-shirt, or some of you may also want to measure the amount of liquid left. So that's fine as well. Just that it's a bit more difficult to measure amount of liquid left because it's in the shirt. So the mass of the shirt will be the easiest to measure. Okay? So you need to measure the mass of the t-shirt after a fixed period of time. Now it's important to do it after a fixed period of time because eventually everything will, both liquids will be evaporated. So you need to set aside a fixed period of time that is not too long as well, so that you know which one dries or which one evaporates faster. Now let's look at question 24. Here they explain to you in the stroking method, when I use the north pole of my magnet and I stroke, eventually what I'll get is this. That means this side here will be north and this side here will be south. So actually what's happening is, if this is north, the part that I leave or I stroke off the bar, this part here will be south, will be opposite of this part here. Okay, so now I have this. So what's going to happen is, so you looking here, the part that I stroke off, this will be south. So here, the part that I stroke off, this would be south. Okay, now the opposite will be true. If this is south, the part that I stroke off, then this will be north. Okay, so that's how you get your answer. So C is south, D is north. Okay, so they already actually give you the answer. You just have to apply it into this new scenario. Alright, so now this person, he now wanted to magnetize the same steel bar. Okay, but this time around he's using two north poles. Okay, so take note, he's using two north poles. Instead of here, it's one north, one south. Now, can that happen? Now remember, because if I stroke off here, this will be south. If I stroke off here, this will also be south. Can this be a magnet? Yeah, cannot, because a magnet must have a north and south pole. Okay, so that's the reason why, because he's using two north poles, and a magnet must have a north and south. So that's the reason why his steel bar can never be magnetized. Alright, so your answer should look something like this. So both ends of the magnet were struck by the north pole of two magnets. So a lot of you were able to give this. Yeah, this is a good observation. But you need to explain. Right, so because of that, the bar cannot have one north and one south pole. And that's, it can't happen because a magnet must have a north and south. So that's the main reason why this steel bar cannot be magnetized by his method. Alright? Now question 25, pre setup experiment. Okay, as shown here. So predict how the setup droplet will move after 2 minutes. Now, so after 2 minutes, so initially what will happen is this will expand. Because this will expand, the ink will actually move a little bit to the left. Okay, but after 2 minutes, what's going to happen is the air inside here is going to get heated up. When it's going to get heated up, it's going to push out. And because it will push out, my ink droplet will move this direction. Okay, so predict how it will move and explanation. So it will move towards Y. So reason being, hot water causes the air inside X to gain heat and expand, causing the ink droplet to move towards Y. Now, part B asking you without changing the glass bottle. So I cannot change the glass bottle or glass tube. So just one change she can make to this original setup to make the ink droplet move faster. Okay, so I want the ink droplet to move faster. So why will it move faster is because this air inside here gets heated faster and pushes up faster, so the ink droplet move faster. So how do I make it expand faster? What I need is for it to have more heat. So how do I have more heat? Well, there are a few ways. One way is for this water to be hotter. Now a lot of you say add more hot water. Now but if you add more hot water, the temperature will still remain the same. So how will it gain heat? So I need more heat. Okay, so that's why you need to add hotter water or put a flame. Now but take note, if you're going to put a flame with the plastic basin, it's gonna melt. So then that's dangerous. So if you want to just say put a flame, it must be put a flame to the glass bottle. So you have to remove this basin with hot water. So when you put a flame, yes, you have more heat. Okay? So what you should do is to basically, the easiest answer is to use hotter water. That's all. Alright, that's the end of the paper. Have fun.